Good day, everyone. Now we continue this topic, second part, multitasking. In the world of programming, according to common sense, the program is a model of a set of series of computer instructions. When it is running, actually it is being executed by a computer processor from the first instruction to the end. A bit more advanced, realize within the series probably there are some iterations, looping, or probably branching, even conditional branching. A bit more advanced again, realize that branching can be done to the outside module. So here is the example of the program in common sense. We call it here is a user one program. Got one module, name it as a net01. And in the system behind that, there is a module with name is netserve reentrant. When it is running, it actually being executed from the first instruction here, buzzer, brand and save register 12, 0, then next LA, next L, and next buzzer. The second buzzer here, once it is executed, then execution control branch to this system module, nature. In here also the same, execute first instruction L, load, then MH, the second instruction, then next instruction ST, then next, then until this instruction branch to the content of the register 10. Once it is executed, then branch go back to this module here, and this location, the instruction is branch register 14, means branch back to the system, branch back to the column. The logic is running serially from this module until this instruction, then go to this module and go back here. What happens if there are two user programs here running at the same time in a single computer, even single processor? Unrealistically, even though there is no other program running beside our program, there is at least one program running beside our program. What is it? Operating system. OS means our program is never alone in the system, and unrealistically OS provide a block of memory to other program. TCB, task control block. The function is to save all the states of the program before it is interrupted. In such situation, there are two user programs, user 1, user 2, and OS provide two TCB, TCB user 1 and TCB user 2. OS also position all the common service, including needs in the set of common segment, and it is protected. Next, let's start to the mechanism of multitasking. Let's say dispatching is started from the user 1 first, means the execution control go to this module, net01. The first execute instruction is the first instruction in this module, which is pointed by entry point address. In this case is branch and save register. To branch to the address consisted in the operand 2 means register 0 and load the next sequential instruction address into the register 12. But as it is a 0, 0 is to represent that second operand is not used. So the only thing got here is a address of next sequential instruction, which is loaded into register 12. Next, load address of data queue here into the register 1. Register 1 is then contain address of data queue. Next, interrupted. This new understanding when we are learning multitasking. Then control go to the OS. OS then doing housekeeping. All the states here in terms of processor registers, PSW are saved into the TCB of user 1. In the TCB, actually not only register and PSW, there are a lot to be saved. But here, I only select some to simplify. Once saving is done, then continue to control user 2. Let's say it is the first time dispatch, so nothing is saved in user 2 TCB, so nothing to restore. Control then to the first instruction in the user 2, which is located in the entry point address here. Execute this first instruction only to update the content of register 12. To contain the entry point address plus 2. Next is load address of var. Var address here is loaded into the register 1, so register 1 updated to contain var address. Next, interrupted. So then control go back to OS. Then doing housekeeping to save all the state of the user 2 in the TCP of user 2. Next, move control back to user 1. As it is not the first time, so restore everything in the TCP to the system. Automatically, PSW is updated to the next sequence instruction of the last executed instruction in the user 1 before interrupt. So this one. Load external address of this common module needs served into the register 15. So register 15 contain address of this module. Next, branch and save register to the address contained in register 15 main address of this module and save the next sequential instruction address into the register 10 means register 10 updated to be contain address of exit 1 here. Not necessarily labeled as already determined next sequential instruction. Then control go to the entry point address of this module needs served in the common storage. At the same time, data queue here as its address already contained in the register 1 here, it will logically as already in needs served area here, which is actually not. It's actually just mapped by this dummy structure. Okay, unfortunately it corrupted again. Control back to the OS, do housekeeping to save everything into the TCP of user 1 like this. Then back to user 2. OS then restore TCP of user 2 to the system. Once everything is including PSW, automatically control point to the next sequential instruction address of the user 2 exactly before interrupted. So it is this instruction. Load address of needs served module into the register 15. So register 15 contain address of this module. Next is press and save to address that contained in the register 15, which is this module, and save next sequential instruction address into the register 10. Register 10 will contain address of exit 2, this one, not necessarily labeled as exit 2. Okay. Afterward, then control go to the entry point address of net serve. Here, the same way, the data in user 2 will be logically as it is being here, which is actually is not, then interrupted. Control back to the OS will save everything, especially PSW and register into the TCP of user 2. Next, check the TCP of user 1 is then restored to the system. Once restore is done, PSW also updated to the next sequential instruction address of the last executed instruction in the user 1, then automatically control will go to the location of that, which is here, branch and save into the content of register 15, which is actually the address of this module. Then execution is begun, starting with instruction load ABC means this one into the register 3. Next, register 3 will contain the data of ABC, which actually the data of ABO1 and user 1. Next, MH multiply hardware content of register 3, which is this data, by the content of PQR, this, the number of time. So the content of register 3 change to the result of this multiplication. Next, store the content of register 3 into ABC PQR located here. So ABC PQR will contain this data, which is actually here in ABC PQ01. Next, interrupted. Control go back to the operating system. Then OS doing housekeeping, save everything here into the TCP of user 1. Like this. Next, go to user 2, but before control exactly going to the instruction in user 2, OS doing restoring first from TCP of user 2 into the system. So the last state of user 2 is back. Once the PSW is restored, automatically control will point to the next sequential instruction address of the last executed instruction before interrupted. Means go to here, branch and save register 10, register 15. Means as register 15 contain of this module address, so control will jump to this module and register 10 will contain of its next sequential instruction address, which is address of exit 2, this one. Next is execution of load ABC into register 3. At this time, content of ABC is not ABO1 anymore. It is WA1 here, 150. So register 3 is updated to contain this. Next, multiply the content of register 3 by the content of memory located in PQR here, 50, which is actually WA3 here. The result will be kept in register 3 like this. This is the result. So register 3 is updated again. Next, store the result into the memory located in ABC PQR here, which is actually this one. Next, load XYZ, this one, into the register 4 XYZ, which is actually WA2. Hence, the register 4 then contain of this one. Next, interrupted. Back to OS, then doing housekeeping, save everything into the TCP of user 2 like this. Then go back to user 1, check TCP of user 1, then restore all of them, including PSW. Once PSW is restored, then automatically control go to the next sequential instruction address of the last executed instruction in the user 1, which is this one. Load XYZ into the register 4. Then register 4 is contain the data from XYZ, which is actually XYO1 here, 25. Next, multiply the content of register 4 with data located in PQR here, which is actually this one, PQO1. The result will replace the content of register 4. So register 4 is then updated to this, the result of multiplication. Next, store the content of register 4 in memory located in XYZ PQR here, which is actually here, XYPQO1. Next, copy the content of register 4 to register 5. Hence, register 5 is then contained here, this one. Next, interrupted. Control go back to the OS, then do the housekeeping, save everything into the TCP of user 1 like this. Then control go to user 2, before execute the user 2, restore the content of the TCP into the system. Once PSW is restored, automatically control will go to the next sequential instruction address of the last executed instruction before interrupted, and it is this one, MH. Multiply the content of register 4 by content of memory located in PQR, this one, which is actually WA3. Then the result will be kept in the register 4. So content of register 4 is updated, this one. Then store register 4 into XYPQR here, which is actually this, hasil 2. Next, copy the content of register 4 to register 5. Then register 5 is updated. Then add the content of register 5 with the content of register 3. This number is added to here, and result will be kept in register 5 like this. Next, store the content of register 5 into hasil 1 here, which is actually hasil 3 here. Then interrupted. Control go back to the OS, everything is then saved to the TCP of user 2 like this, and then go to user 1, check the TCP of user 1, restore everything in the TCP into the system, including PSW. Once PSW is restored, then automatically control go to the next sequential instruction address of the last executed instruction, this one. Add the content of register 3 into register 5 and update the content of register 5 with this result. So register 5 will contain this. Afterward, store content of register 5 into the memory located in hasil 1, this one here, which is actually here, hasil 101 in user 1. Next, copy the content of register 4 to register 6. So register 6 is updated. Next, subtract the content of register 6 by the content of register 3 and keep the result in register 6. So register 6 is updated again with this. Then store the content of register 6 into the hasil 2 here, which is actually here, hasil 201 in user 1. Next, interrupted. As usual, back to OS, then save everything into the TCP of user 1 like this, and go to user 2. Check the TCP, restore as TCP including the PSW. Once the PSW is restored, automatically control branch to the next sequential instruction address of the last executed instruction before interrupted, which is this one. Copy the content of register 4 into register 6. So register 6 is then contain this one from register 4. Then subtract register 6 with register 3. The result is then stored into the register 6. So register 6 is updated, become like this. Next, store the content of register 6 into the hasil 2 here, which is is actually this one. Hasil fall in user 2. Next, branch register 10. Branch to the address contained in the register 10. What is it? This one. Address of exit 2. Here is exit 2. So control go to this instruction. In this instruction means unconditionally branch to the memory contained in the register 14. So what it is? It is actually from the caller before everything is done. From the operating system means go back to the operating system serially, then finish. So once it is finished, control go back to the OS, check the TCP OS1, then restore it to the system, including the PSW. Once PSW is restored, then control automatically, as usual, go to the next sequence instruction of the executed instruction before interrupted is exit 1. This one. This. Branch to the memory contained in register 14. What is it? Is it from the caller, from the OS? Then finish with the result already in the working storage of each user. That's the example of a very simple mechanism of the multitasking. Thank you for watching. Good day.